Dawn's Smooth Move, presented by Science at NASA. When a NASA spacecraft goes into orbit around a new world for the first time, the control room is usually packed to capacity with scientists, engineers, and dignitaries ready to leap and shout when the retro rockets fire. It's a big, noisy event. July 15, 2011 was one of those days. NASA's Dawn spacecraft approached Vesta and became the first probe from Earth to orbit a main belt asteroid. Dawn's cameras revealed a desolate world of transcendent beauty, thrilling everyone who works on the project. Needless to say, the control room was silent? Actually, it was empty, says Dawn Chief Engineer Mark Raymond of NASA's Jet Propulsion Laboratory. Dawn entered orbit on a Friday night. I myself was out dancing with my wife and friends. What gives? Raymond, an avid folk dancer, explains, I really was out dancing, confident that the pas de deux being performed 188 million kilometers away would be executed with flawless precision. Indeed, Dawn is unprecedented. While most spacecraft blast off Earth atop a firestorm of conventional rocket exhaust, then coast to their destinations with engines turned off to conserve fuel, Dawn was able to continue thrusting throughout its voyage. Dawn's fuel-efficient ion engines gently propelled the spacecraft toward Vesta for more than 3 years, never exerting more force than the weight of a feather held in your open palm. Yet, over time, gathering enough speed to catch an asteroid racing halfway across the solar system. With the ion engines firing almost constantly, mission controllers were able to actively steer the probe, gradually reshaping Dawn's orbit around the Sun until it matched the orbit of Vesta itself. Meeting Vesta for orbital insertion wasn't a jarring encounter of mismatched velocities. It was more like two dancers merging in practiced rhythm to a familiar tune. Dawn did not miss a beat as it flew into Vesta's grasp, says Raymond. The spacecraft moved gently into orbit with the same grace it has displayed during its nearly 1,000 days of ion propulsion through the solar system. Calculations show that the moment of orbit insertion occurred on Friday night, July 15th, around 9:45 Pacific Time. At that moment, Dawn's orbit around the Sun finally was so close to that of Vesta that the protoplanet's gravity could take hold of it. Radio signals picked up by the Deep Space Network on July 16th confirmed that the spaceship and asteroid were truly a pair. Dawn will spend the next year circling Vesta in a series of descending passes, bringing the giant asteroid's surface ever closer to Dawn's cameras and other science instruments. Because Vesta is a relic of long-ago planet formation, a glimpse into the ancient history of our solar system could be revealed under Dawn's careful scrutiny. This really beautiful dance, says Raymond, is just getting started. For updates from Vesta and more smooth moves by NASA spacecraft, please visit science.nasa.gov.
Space Station Meteor, presented by Science at NASA. On August 12th and 13th, Earth passed through a stream of debris from Comet Swift-Tuttle, source of the annual Perseid meteor shower. Around the world, millions of people watched bunches of bright and colorful Perseids streak across the moonlit sky, but only 6 people saw the shower from above. High above Earth's surface, circling the planet at 17,000 miles per hour, the crew of the International Space Station watched the shower too. This is what a shooting star looks like from space, tweeted Expedition 28 flight engineer Ron Garan, who photographed a bright Perseid streaking beneath the space station. At the time of the shot, 1917 Universal Time on August 13th, the ISS was over China, moving from the Gobi Desert near the Mongolian border toward Beijing. This isn't the first time astronauts have seen and photographed meteors underfoot, but this could be the most beautiful shot to date. In my opinion, this is the finest still image of a meteor from the International Space Station or any spacecraft, says Bill Cook, director of NASA's Meteoroid Environment Office. Good catch, Ron. Cook has analyzed the image. Based on the meteor's apparent brightness, he believes Garan caught a nugget of comet debris about 1 centimeter in diameter, hitting the atmosphere at 132,000 miles per hour. The astronomical magnitude of the meteor was about -3. very nearly a fireball, says Cook. Other objects of interest in the photo include the orange giant star Arcturus, brightest member of the constellation Boötes, the herdsman; Corona Borealis, the northern crown; Serpens, the serpent; solar panels of the International Space Station, and a Soyuz spacecraft docked to the space station. A layer of green airglow. Airglow comes from atoms and molecules in Earth's upper atmosphere, which are excited by sunlight during the day. At night, they release their energy as a green band of light visible from orbit. Cook is convinced. Next year, he says, I want to watch the Perseids from orbit too. For more information about things you can see from space, visit science.nasa.gov. A breath of fresh air in the Orion Nebula, presented by Science at NASA. Take a deep breath. You just filled your lungs with about 1,000 billion oxygen molecules. There are oxygen bars in California where you can actually pay for a deep breath of O2. But in most places on Earth, molecular oxygen is free and abundant. The gas makes up almost 21% of our planet's atmosphere and is ubiquitous. Astronomers have just announced the discovery of this same gas in outer space. Here on Earth, oxygen was discovered in the 1770s, says Paul Goldsmith of the Jet Propulsion Laboratory. Early chemists called it fire air because of its combustible properties, but it has taken us more than 230 years to finally say with certainty that this very simple molecule also exists in space. Goldsmith led a team of astronomers who used the European Space Agency's Herschel Space Telescope to search for signs of molecular oxygen in star-forming clouds. Herschel senses far infrared radiation invisible to the human eye. It just so happens that the molecular oxygen can be seen at these long wavelengths. Goldsmith's team found the telltale signs of O2 near the core of the Great Orion Nebula. The 2 in O2 is crucial. The oxygen we breathe on Earth is diatomic. That is, 2 oxygen atoms joined together to form a dumbbell-shaped molecule. Single atoms of oxygen are highly reactive and can even be corrosive. But when you put 2 oxygen atoms together, it's a breath of fresh air. Astronomers have long known that the reactive atomic form of oxygen is abundant in the universe. It is found in gaseous nebula, the atmospheres of stars, and many other places. This new discovery by Herschel shows at long last that the familiar diatomic form of oxygen is out there too. Curiously, the oxygen found by Goldsmith's team is not a free-floating gas. It appears to be mixed up in an icy frosting which coats grains of space dust in the nebula. This explains where some of the oxygen might be hiding, says Goldsmith. But we didn't find large amounts of it, and still don't understand what is so special about the spots where we find it. The universe still holds many secrets. Star-forming clouds tend to be dusty places, so there could be lots more O2 hiding out there. Goldsmith says the team plans to continue their hunt for this familiar gas in other clouds beyond the Orion Nebula. Out there, he knows, is an elusive whiff of Earth among the stars. For more fresh air in science news, visit science.nasa.gov. Paying a visit to Pluto, presented by Science at NASA. At this very moment, one of the fastest spacecraft ever launched, NASA's New Horizons, is hurtling through the void at nearly 1 million miles per day. Launched in 2006, it has been in flight longer than some missions last, and still has 4 more years of travel to go. New Horizons is headed for the lonely world of Pluto on the outer edge of the solar system. Although astronomers now call Pluto a dwarf planet, it's actually a large place, about 5,000 miles around at the equator, says Alan Stern, principal investigator for the mission. And it's never been explored. Indeed, no spacecraft has ever visited Pluto or any dwarf planet in the outer solar system. This is a whole new class of worlds, says Stern. To understand the solar system, we need to understand worlds like Pluto. Pluto is a resident of the Kuiper Belt, a vast region beyond the orbit of Neptune. Stern believes the Kuiper Belt contains 1,000 dwarf planets or more, a whole zoo of them. Dwarf planets are, in fact, the most numerous class of planets in the solar system, and probably in the whole universe. Pluto is a world of mysteries. For one thing, Stern wonders, what are the molasses-colored patches on Pluto's surface seen by the Hubble Space Telescope? Some scientists think that they could be deposits of primordial organic matter. New Horizons spectrometers will help us identify the kinds of organic molecules on Pluto. We expect to find something pretty interesting. Hubble recently contributed more intrigue by spotting a new moon circling Pluto, bringing the total to 4. Composite Hubble images of Pluto now resemble a miniature planetary system. New Horizons will hunt for even more moons as it approaches the dwarf planet. To aid in the investigations, New Horizons is carrying one of the largest and highest resolution interplanetary telescopes ever flown. It's called LORRI, short for Long Range Reconnaissance Imager. At closest approach to Pluto, LORRI can resolve details almost as well as a spy camera. The view will be incredible. If we flew this instrument over Earth at the same altitude as we plan to fly over Pluto, we would see individual buildings and their shapes. What will we see on Pluto? Some researchers predict icy geysers like the ones on Neptune's moon Triton. Some say we could see those surface deposits of organic material. Stern says simply, there could be all kinds of surprises. It's a first exploration of a new kind of planet. New Horizons is scheduled to reach Pluto in 2015. For mission updates, please visit science.nasa.gov.